Good night, my name is Diego Bustos and now I'm going to show you my presentation about hierarchy in Java. And I'm going to make an example with a quadrilateral class. That it's a good example, you will know why, so let's go ahead. Okay, first of all, I'm going to show you a diagram that is the way how I'm going to do my code. So, here I'm going to show you the idea that I have. My primary class and, and this have all the important attributes. Also, it has the two methods that I'm going to use for all the other class. Now I'm going to show you parallel, that is the second class that I'm going to make, and this class is a little bit particular because it is going to have other attributes that are side 1, that is with another name, but you will have it in mind, and side 1 and side 2 that also has the double attribute. I didn't mean this, but side DC, AD, BA, and CD also are going to be with double. Why double? Because double understand both int and char. So it's the best way to use these attributes, because we are going to do some calculations like the perimeter and the area of the geometric figures. So here in parallel I also have the super. Why the super? The super is an attribute that we get by extending our class with another class. Okay. This means that when we extend some when we extend one class with another class, we make a connection between these two classes. So the attribute super is going to take these four attributes, and they are going to be inside here. Why is here just two types of attributes? Well, it's because in parallel we are going to use just two sides. We are not going to use four sides. So in parallel we just use two sides, and we must do have four attributes inside the super, because we are extending from quadrilateral. So also we have the method that is the calculation area, that we also have it in quadrilateral, but in parallel is a little bit different, so we have to override this method. Now we are going to pass with the third class, that is rectangle. Rectangle is a parallel, so we will just say that it's easier that say that a rectangle is a parallel, and also happens with the square to the square. So rectangle and square have both sides the same. So that's why we are going to extend these two classes to parallel. And the extension of rectangle, we can see that in this case do we also do in parallel, that is introduce two new attributes that are called base and height. And as we can see, we use just a super with two variables, with two attributes. This means that in parallel, why we just use two attributes, then our super is just going to be based of two attributes. The same happens with a square. In a square, we just have one side, but with just that side, we need to make the super with two attributes, because we are extending to parallel. Okay, so let's continue. Okay, now I'm going to show you the structure that I do my project in Java. And here I have my project that is called a square, and I open two packages. The first package is called Quadrilateral, that is going to contain all the Java projects that I'm going to put the attributes and the classes that are going to have the quadrilateral stuff. And here in the second package, that is the view, I'm going to make the main that is going to show all the process in quadrilateral. Okay, and I'm going to show you what is quadrilateral and how I made it. In quadrilateral, I introduce the attributes that are side AD, BA, CD, and DC. All of this is protected by the numeral sign, and that this means that this protected attribute is going to literally protect or the value of this attribute, so it can be overwritten or everything. Uh, Also, it have double thing. Now I'm going to show you the constructor that is uh, the double L1, double L2, double L3, and double L4. Why do I put L1, L2, L3, and L4 besides AD, BI, CD, CP, or DC? Because I want that the code is more easily to read. So when I made this construction, I made his respective this point L1, this point L2, and the other ones. With that things in mind, I put all the getters and setters that we called the getters that are in these attributes, and we have the setters that are going to be in the others um, classes, and these ones are going to be with the attribute double, and they don't need it because they are just the call of these attributes. Now we have the methods that are calculate perimeter or calculate area that are going to be also into the other classes that we have arranged. Now we pass to the test that I made with the code already done, and I have the case one that I just made the process with quadrilateral and is just putting, well, same to the usual to put four different numbers to have a perimeter and area, and that's it. Now here in the case 2, I will take the parallelogram that is to take the perimeter and the area. In the case 3, I have the rectangle that is almost the same of the parallelogram, but the the rectangle has a little bit different. That is nothing at all. It just have the perimeter and the area, and that's it. The case 4, in the square, I just made that the user put one number because a square have in all these sides the same. So that's it. Okay, so we pass to the questions, and I'm going to answer these 7 questions that are part into this presentation. And then we start. Why is the quadrilateral a good candidate for a superclass? Uh, because quadrilateral defines common attributes, the 4 sides, and the methods like calculate perimeter and calculated area that are going to make an easier subclasses the to the RLC, uh, and this making that the subclasses have an easier way to share this functionality. Okay, second one. How does inheritance help to reduce code duplication in your design? And Instead of redefining attributes and methods in every subclasses, ignorance allowed them to reduce code from quadrilateral and made that each subclasses only needs to override methods when it's necessary. And that is one. If you were to extend this hierarchy further, what additional subclasses would you add and why? And I would add like polygons, well, other subclasses that have subclasses inside of that subclasses, like for example, as we know, we have parallel that has rectangle and square. So I will do another subclass that will have another subclasses like a trapezed, or well, I will say in Spanish because I don't know how to say it really great English. So I will do a trapecio that will have inside of that subclass another subclass that will be trapecio isosceles and will have another subclasses like polygons, diamonds, or something like that. And I will like it because it will take the main sense of this code that are the the sides, the right sides. I don't know how to say it, so I'm going to say it in Spanish. Tiene el sentido de que toma en particular los lados rectos que ya tenemos predeterminados en el cuadrilátero. Okay, for question. Why is the quadrilateral class abstract and what are the benefits of using an abstract class in this case? Making abstract prevents directly instantiations and enforces subclasses to provide specific area calculations and also enchants code or, and also makes that the code is more organized and it could make it extendable. Okay. 5. How does method overriding improve the flexibility of your design? Subclasses can redefine methods like calculation area to provide their own logic, so ensuring accurate calculation for different quadrilaterals. And this making the the calculation area have a different method to do because, as we know, now all the geometric forms have the same calculation area. 6. Can you give me an example of polyformings in your implementation and how does it work in this project? Okay, polyformings allows a subclass objects to be treated as an instance of its superclass. This means that we can use quadrilateral reference to store any subclass objects like rectangles, squares, etc. And when calling overriding methods, the correct version from the subclasses is executed. This makes it simplifies the method calls and reduces code duplication because we don't need separate logic for each quadrilateral type. So that's it. And the seventh question is, what challenge did you encounter while implementing the hierarchy? And principle, I think the ensuring correct formulas for all the quadrilaterals and trying to find out how to understand the super extensions of every class and deciding how to store additional properties inside of them. And I think that's it. So, thank you for watching. See you later.